Okay, so let us try to understand how to trace a simple hydraulic circuit. As shown over here, we'll first try to understand the various components of the hydraulic circuit. So this is the receiver from which the fluid will be pumped by the pump, and the pump is driven by electric motor. This is the strainer which is used to filter that particular fluid. So the pump is fixed displacement pump and it is unidirectional pump. It is rotating in only one direction. It is driven by the electric motor as shown over here. The cylinder that we have shown is a single acting cylinder. The fluid is acting only on one side of the piston. Pump pumps the fluid from the receiver, and then that particular fluid is sensed by this relief valve. If the pressure is excessive than as compared to that of the design pressure, generally it is normally closed position as we have shown over here. But if the pressure exceeds a certain design value, then it will open, and we can say that this arrow that we have shown over here will assume the position in this particular direction. So the position will be like this, and again the liquid that will be flowing from this pump over here will be coming over here, and then it is going directly again back to the receiver. So no further operation will be performed if the pressure is excessive, correct, or if it exceeds the design pressure. Then this is the pressure gauge which indicates the pressure, and this is the shut-off valve as shown over here. Now this is the most important part of any hydraulic circuit. So here we have shown 4 ways. So these are the 4 ways: P, R, 1 and 2. These are the 4 ways. P stands for the pump port, R for the receiver port, 1 that is the inlet that is given to the cylinder, and 2 will be the outlet from the cylinder, or vice versa. So here this is the center position, and it is the block position. If the fluid it comes from the pump and it enters at this particular port P, then nothing will happen. The position of the spool inside the direction control valve is such that all the ports they are blocked and no operation will be performed. Rather, no fluid will be given to the cylinder. Now, as we have shown over here, it is a lever operated and spring controlled direction control valve. So when we operate this particular lever in such a way that suppose we get the left envelope mode, then we can say that this P and R will be present over here. P and R. Similarly, this 1 and 2 will be present on this particular side, and the fluid from the pump will enter this port P. From P it will go to 1, okay? And from this 1 it will enter through this restricted opening, and it will pressurize this. The force will be acting on this piston, and it will cause the piston to move in the forward direction. That is known as the feed direction. The liquid from the other side will enter this port 2, and from 2 it will go to R, and then it will go back to the receiver. When we operate the lever or release the lever in such a way that we get the right envelope mode, then we can assume this particular position that is present over here. So P will be over here, R will be over here, then 1 and 2 will be over here. So the operation of this particular left and right envelope mode will be shown in the next animation. So this is the 4-way 3-position direction control valve. So these are the 4 ways: P, R, 1 and 2, and there are 3 positions. So center, block position or closed position, then left envelope mode and right envelope mode. This lever operated spring control. Another important component of the hydraulic circuit is this particular flow control valve with the integral check valve. This is the check valve. It functions in such a way that it will allow the fluid to flow only in one direction. Now when the fluid comes over here, for example in this particular position, then it is a no free flow condition or no flow condition for the check valve. So liquid cannot flow in this direction, so it has to compulsorily flow through this restricted opening and then enters on this particular cylinder end of this particular single cylinder. Now let us try to understand the forward motion of the piston through this animation. So liquid from the reservoir or receiver, it is pumped by the pump, okay? Then it will enter to this port P. From port P it goes to port 1. From 1 it will enter to the port 3, and the fluid will be allowed to act on this surface of the piston so that it will move in the forward direction. The liquid from the other end, that is the rod end, will enter from 4 to 2, and from 2 it will go to the reservoir, so from 2 to R. So in this way you can trace this particular hydraulic circuit. So here, now we try to understand how this particular flow control valve works. So here the liquid will come over here. It cannot go from this side because this is a no flow condition, but it has to come, it has to flow through this restricted opening. So piston will move slowly in the forward direction. So this is our left envelope mode. Now we'll see the right envelope mode. So let us animate in such a way that you can easily understand this particular concept. So now from the pump, the liquid is allowed to enter over here. From this side it will go to this port. From this to this rod end of the cylinder will cause this piston and piston rod arrangement to move in the backward direction. The fluid from the other side will enter over here, and from this it will go to the reservoir. But now you can see it can easily flow through the check valve because this is the free flow condition, correct, of the check valve, as well as it can flow through this restricted opening also, correct. So the backward motion will be fast because there is no restriction to the flow of the fluid from this port to from this port 3 to the port 1, and from 1 to R, and then to the reservoir. So in this way we can trace the simple hydraulic circuit.